Hi everyone, as you heard, my name is Mark Dalgleish and I'm here all the way from Melbourne, Australia. Thank you so much for having me here today in such a beautiful city. Now, one of my passions, if you follow me on Twitter, this is no secret to you, one of my passions is design, and particularly the intersection of design with technology and how it affects the way we build applications. So for the purposes of today, what I really want to talk about is rethinking design practices in our daily work and what we can do to help achieve this. Now, I think our industry is at a crossroads. I talk to a lot of people who are working in this space, and everyone says the same thing. Everyone's struggling with this. Our design systems aren't fully delivering on their potential. The more and more we invest in design in code, the more we feel this disconnect between the two disciplines, and everyone's struggling to make sense of it. Our design is increasingly defined in code. This is something that we're pouring all of our efforts into, and yet design workflows are struggling to keep up. Last year, I was here on this very stage talking about how we can export from our React-based component library, as we have, into a static design tool like Sketch. And then I talked more about other design tools that are trying to embrace components as a first-class medium. But ultimately, no one's fully cracked it yet. We're all struggling with this. So our industry has a choice to make. There's two radically different ways we can tackle this problem. The first is obviously the most attractive at first glance, which is bringing code and the work that we're doing into design tools. And this is what we're seeing with newer tools like FramerX. But there's also another angle, which is actually embracing code as a design medium and designing in code itself. Designing in code is the angle that I'm going to look at today, and it's the one that really excites me the most, I think, because I think it really has the most potential to change the way we think about design as an industry. And that's because by working in code as a design medium, designers and developers will literally speak the same language. With design systems, we talk a lot about trying to speak the same language, and these new tools that we're looking at might get some ways towards us thinking the same ways, but ultimately we express ourselves very differently. I think if we break down the walls between code and design, there's a massive opportunity there for us to change the way we think and the way we work. Now, I work at Seek in Melbourne. In Australia, this is a household name, obviously less well known here. It's the leading job site there. And at Seek, I work on the design system, among other things. Braid is our design system, which is open source. So if you want to go have a look at it and see what we're doing in this space, please go check that out. Now, what I want to talk to you today is how we're solving this and some of the hard lessons we've learned along the way and what we're trying to do into the future. So hopefully this resonates with you and it's something that you can take into your work when you resume that next week. So there's three top high-level things I want to cover today. The first of which is tooling. The second, which is the abstractions you need in your design systems to achieve this goal. And the last is the workflow that we want to build on top of that. So let's start at the top, which is with the tooling. Now, it was actually, again, on this stage last year that I unveiled for the first time a tool that I'd been working on and that we'd been using at Seek called Playroom. Now, Playroom is a tool for letting you design in the browser with components that you've built. But the key differentiator over other tools is that Playroom treats JSX as a design tool rather than trying to abstract it away behind a drag-and-drop UI. So in practice, it looks something like this. You can see there at the bottom a pane of JSX that you can write, and you have full access to the component library that you've plugged into it. It supports theming, which is something that we needed for our system. So as you can see along the top there is an iframe for every single theme. Off the screen to the right, if you were to scroll across, you would also see different screen sizes, so it's useful as a responsive design tool as well. So here you can see you're describing the UI in the components that you've developed, and if you find that something's missing, it's up to you to plug that in as part of your component library. So this has been an invaluable tool for us to be able to get our design system circulated throughout the company. And that's because of two important factors. The first one is that it's zero install, it's web-based, so people don't need to set up a complicated developer environment. This is particularly important if you're trying to reach out to non-developers. The fact that they can just click a link from the design system website and have that up and running has been invaluable. And the second part of it, of course, being in the web browser means that we are able to have shareable URLs. So someone can throw together a UI design very quickly, send it to someone in Slack, and get some feedback, and maybe they change it, send it back and forth. Again, this has been invaluable for us to circulate the knowledge of the design system within the company. For me as a developer working on our component library, this has been a crucial tool for me to test drive your design language. So what this does for me is it lets me simulate that end user experience of having a blank canvas. In theory, if my design system is powerful enough, I should be able to compose up a brand new UI from scratch very quickly. And if I can't, then obviously I have some more work to do. And this has been the best way for me to get that feeling. So the next thing I want to talk about is abstractions. And of course, a design system is ultimately one big abstraction. But it's all, the big message I want to get across to you today is that your job as a design system developer is to accurately model the way designers think. It's effectively domain-driven design for the world of visual design. Designers should be able to make sense of the code you're writing. And in order to achieve this, we need to build up in layers, of course. But each of these layers discretely needs to make sense from a designer's perspective. So the first stop along the way is design tokens, or you can think of these as your theme variables. So this is where you centrally define your palette of typography, spacing, color, borders, shadows, breakpoints, things like this. You could go on and on. Ideally, this palette is relatively limited. Design at scale is all about constraints and limiting yourself to that repeatable palette that ultimately defines your brand. So a good example of this is something like spacing in a system. Rather than having random numbers everywhere for spacing things out, you should try and constrain yourself to a limited palette like this. This is actually the palette we use in Braid. And you see we go from XX small all the way up to XX large. And all of these are multiples of our grid, which is 4 pixels. So that means that when you're designing a UI, you're pulling from this palette when you're spacing things out. There's a lot less room for you to diverge across different screens. Once you've got your design tokens in place, you can build up into primitives, which is where you ultimately wire them up to components. A big inspiration for me in this space was Styled System. If you haven't seen this, this is a really incredible library. We don't use it ourselves, but we've taken a lot of inspiration from it and taken a lot of ideas from it, which is something I think you should do either way, regardless of what you're doing. At the end of the day, it really just boils down to this idea of having a primitive component like box, which is what gives you the convenience of pulling out these design tokens and wiring them up to an element on the screen as quickly and easily as possible. So as a practical example, here we see in Playroom I'm rendering a box, and I'm setting a background color of positive light, and I'm setting the padding to be medium. So you'll notice here that I don't have to create a style sheet and wire it up to the element. I don't have to pull variables off a theme and put them on the right CSS properties. I just have these top-level props on that component ready to go with types defined for that and everything, given it's, in our case, it's written in TypeScript. So this is a really good way to speed up the development of new UI, and in a Playroom environment, it means all of your hard work is available to anyone, regardless of their development expertise. One of the best ideas of Styled System that you should definitely steal is this idea of responsive props. Basically, the idea is this, that if you want to define padding, for example, on an element, typically you might pass a single value of small or large, but in this case, I'm passing an array literal that has 2 values of small and large. So in this case, what I'm saying is that on mobile, I want the padding to be small, and on desktop, I want the padding to be large. Again, I'm not having to write a style sheet here, and I'm not having to write a media query and make sure I've got all the rules correct. These sizes are already predefined on our primitive component, and so now it's very expressive for me at this higher level to build up something as dynamic as this. So in practice, again, it looks like this. So that example we saw before, now we're using a responsive prop for the padding. And because I'm changing that second value, the mobile view is staying untouched, but the desktop's padding is changing. So it gives you a lot of flexibility very quickly to try out different designs. The goal here is to make writing CSS the exception. You want to be operating at the component level as much as you can, and getting these primitives right is a key way to enable this. Of course, with these primitives, you're going to build higher-level things like buttons, fields, menus, and so on. These things are a lot less contentious. They're easier to get right. They're much more easily understood by non-developers. So I'm not going to go into much detail here. I'm going to assume you should have not too much trouble with these. Where things do get a bit trickier, though, is when you come to the world of layout. This one takes a little bit more consideration. And in fact, in our case, it took us quite a while to really figure out the best approach for this. So this is ultimately what we've landed on. For me, the biggest inspiration here was a really great article by Nathan Curtis from 8 Shapes. called Space in Design Systems. And he goes really deep on this topic of how you look at a UI like this and break it down into its discrete parts in terms of white space. What are the different moving parts? What do we call them? How do you standardize this? And this is really critical for us if we're trying to build out design systems that make this sort of layout as easy as possible. One really important rule, if you want to do layout well, and I've learned this the hard way, is that components shouldn't contain surrounding white space. If you render a component on the screen, there should be nothing around it in terms of white space. And that's because white space is owned by layout components. These are these two concerns you need to separate when it comes to laying out a screen and components. But there's a problem. It's easy enough to get people to accept this rule, but the browser itself actually breaks this rule right out of the gate. What do I mean by that? So if I render a piece of text and I inspect it in developer tools, this probably looks normal to you. This looked normal to me until about a couple of months ago. But there's a big problem here. This is breaking the rule that we just said, which is having zero surrounding white space on our components. From a design perspective, if you talk to a designer about this, the top of this element is the top of the capital letter. And the bottom of this element, visually, is the baseline of the text. And yet the browser's given us a chunk of white space at the top and a chunk of white space at the bottom. So that means now that in our design system, without realizing it, we're probably going to be fighting this. If you look back at your work over the years, once you see this, you'll probably realize that you've spent a lot of time fighting this problem. So that means in practice, when you stack a bunch of headings, for example, there's going to be some space between them. It's going to look something like this. Now, again, this might seem normal to you at first glance, but imagine if these were buttons, for example. There would be zero space between those buttons. But because we've used text here, we have space between them. From a visual design standpoint, if you are critiquing this, the first thing you might notice is the fact that the white space is not balanced around the internals of this card. So the left-hand gutter there is more narrow than the space at the top and bottom of the card. And there's really no way for us to fix this at the component level. The component itself, the H1 in this case, is doing the wrong thing. So how do we fix this? We've come up with a solution internally for how we do this. There's two steps to it. The first is we use a transform to pull the text down so that its baseline sits on the bottom of the container. And then we effectively crop the top of the text node by rendering a pseudo element before it with a margin top of minus a height correction that we've calculated. So I've omitted a bunch of calculations here that you need to do based on the properties of the font, the cap height and the descender height. If you want to see the specifics of this, go check out Braid Design System on GitHub and you'll see the more long-form version of this. But that's really the concept, is pull the text down, crop the top of the node off. And so that means that when we render our stack of headings rather than H1s, it's going to behave more correctly in regards to our system. Because now you'll see that the top of that capital letter at the very top of the card is balanced in terms of white space of the top and the left-hand side. There is no space between each of those text nodes. And then the baseline of that last one, again, is evenly spaced with that left-hand gutter. This is critical to building a system that's predictable, that works the way designers think, and that's ultimately our goal. So the important thing now is that text behaves like every other component in our system, so we're free to build better abstractions on top of this. And we're mapping to the designer's mental model. Again, ultimately, that's the goal of a design system. Now that we've sorted out the white space around text, which is the most common part of your UI, we're free to build good layout components on top. So I'm going to show you what this means with a few examples. I'm going to start with my favorite, which is the stack component. This is probably the most widely used one in our system. At a code level, a stack looks like this. It's a component that you wrap around a bunch of child nodes, and then you define the space between them. So visually, it looks like this. So you can see here I've got a heading, I've got some text, I've got an action bar at the bottom. And I'm tweaking that space prop to go from small, medium, large, and so on. And you'll see that it's fanning out all of its child nodes evenly, but only space between them, not above and below. So that means that the top of that capital letter on the heading title there is hitting the top of the padding, the bottom of the padding of that card. And that marries up with what we see at the bottom with the button hitting the padding at the bottom. Inline is another good layout component, which is used for things like laying out badges at the top of a card, which you'll see shortly. Again, at a code level, it looks the same as stack. You put a bunch of child nodes in it, you define the space between them. But in this case, what an inline is for flowing content like this. So again, I talked about badges. This is a very common UI pattern. So what we're saying is that with a single prop, we want to evenly space out horizontally and vertically between our badges. And the key thing is that we're making sure within this component that we don't introduce that surrounding white space. That last line of badges will not have a row of white space below it. The bottom of the container hits right up against the bottom of those badges. And if it doesn't wrap, then it takes up a single line. So now very quickly we can operate at this higher level, thinking like a designer, making a single decision that impacts this entire component in terms of spacing. Columns is a little easier to deal with because everyone knows what columns are. Here's what it looks like. Now, this one's a lot simpler, as I said, but you'll see here that the layout is honoring those design tokens that we've just specified earlier. So just by changing this one prop, the space between our columns is fanning out evenly. But the great thing about our system building up in layers is that the responsive props that we defined as a feature down at the box layer is potentially available up at these higher components. So in this case, the columns component actually does support responsive props. So if you want to say that your columns have small space between them on mobile and large space on desktop, you can express it as easily as this, which consumers of your design system no doubt will appreciate. Again, the key thing here is that we map to the designer's mental model in terms of the way they manage white space. Because if you ever watch a designer work, they tend to drop the elements they want on the screen as a first pass, and then as a second pass, they're dealing with the white space. They're dealing with the layout. They're nudging things up and down to make sure that things sit correctly on the screen. And this, as a component system, is basically giving them that same mental model. Now, up to this point, if you've done your job well, your components should make sense to non-developers. They should be able to look at the code that you're writing and be able to follow it completely. And not only that, but they should actually be able to start to roll up their sleeves and write it themselves. And that's really the idea with this tool, is that you're creating an environment that's a lot more inviting for people who are not as experienced with development. Because you've trimmed away everything that's tricky about React in terms of your development environment. Even the fact that you have to write a function that returns JSX is gone, and you're just writing the raw JSX. And so now we have a tool that we can use to bring other people along with us on this journey and start to learn the components in our system and try them for themselves. I think this opens the opportunity for us to start to make code part of the design process. If we've done our job well, this should be possible. So to me, what this means is prototyping in code. There's still a room, there's always going to be room for pencil and paper at the very least. And even tools like Sketch are great for trying out rough ideas before you want to invest too heavily. But what I want to push for is this idea of getting into code sooner than we do today. Often we treat code as the thing we do at the very end of a design process when we're ready to ship to production. I think we need to change that around and get code in there much, much earlier than we do today. So how can we help? There's a lot of work here for us to do to make this happen. From a cultural perspective, I think we need to get involved with design. We need to start sitting with designers in their own spaces, seeing how they work, and really trying to understand what they need from the system. Hopefully you've been doing this already to build a design system, but even when you've got that far, you need to keep doing this. This is really critical. In particular, I think you need to pay attention to how designers iterate, because if we want to be able to design in code, our code needs to be flexible enough to deal with all the different iterations that they go through. So keeping an eye on this is really important. This is quite a big leap, obviously, and I'm very aware of that. And so what you need to do is find those early adopters and offer constant support to them. So in our case, what we're doing is we're running a Slack channel internally for people who need design support with our system. And we've tried to make it as much as possible a place where people feel welcome to ask questions, to surface the problems they're having, to share Playroom links around and get feedback. And we've had some early wins there, and it's been really positive for us. Once you start to go outside that group of early adopters, a really good strategy is to encourage pairing between designers and developers, which probably should be happening anyway, but this starts to give you a place to do that in a dedicated way. So if you sit down a developer with a designer in front of this tool and they start to try and translate their early concept work into JSX, that feedback loop gets nice and tight now. What I want to propose is this idea of JSX as a design tool for everyone, not just for developers. I think it opens up the door to making our design language something that can be expressed very quickly and easily in a way that really crosses this boundary between design and development. That means us as a community need to welcome designers into the fold at large and within the companies we work in. This is the really critical step I think that we need to get right. Getting things technically right is not enough. We need to move the needle on the design process itself. And I really think there's an opportunity here for us to do it. In order to do this, we need to use code-oriented design tools. Maybe build them for yourself if you need to. Take Playroom, fork it, and add your own features if you like. In our design systems themselves, we need to make sure we create the right abstractions, and right meaning mapping to the way designers think about things. In order to achieve that, we need to work closely with designers and make sure that we really deliver on the potential that they need. And then finally, we need to actively support new workflows that are opened up as a result of this. It's really our job to do this. So if we really want to do this, if we really want to start rethinking design practices, this isn't going to happen without the people in this room. So hopefully this is resonating with you, and hopefully you think this is something that is possible and has the potential to really improve the quality of the products we ship to our end users and let us move a lot faster while we do it. So I'm hoping you'll join me on that journey, and I'd love to really change the way we think about design. That's it for me. Thank you for listening, and thank you.
Mark Dalglish, everyone, the co-creator of CSS. And Mark, we have a bunch of questions. I like the idea of layout components, but don't developers get worried about the extra DOM it brings? DOM?
Yeah, so I put this in the category of I'm happy to cross that bridge when I come to it. I think you have two competing problems here, and there's always a cost to abstractions, but I think that this abstraction is worth it, but we'll see.
Are stack and inline based on wildcard selectors?
No. From memory, we wrap each child in a container, I think, but I could be wrong. I'd have to double check.
It's nice to know that you have to double check something.
Yeah.
There are tools for developers to help them use normal web headings in design. Wouldn't it be easier to provide them this than redefine basic fundamental element?
So I'm not sure I understand the question.
Me either, but I tend to not to understand those questions. Let's be honest. I thought JavaScript was something that Java wrote. It's not, I know. I mean,
I'll address the last point, I guess. Redefine basic fundamental element. I actually think this is the crux of some of the issues we have trying to cross this divide, because effectively what you're doing is you're calling out what the browser's doing natively as being incorrect. And that actually, I would say that goes against our nature to do that. Like, I was unable to find this issue for quite a while because I just took for granted that that's the way things work. It's one of those things you don't question. But it took me sitting with designers and really talking through why they're struggling with the design system and why it's not doing what they expect, to really understand why this extra white space around text nodes is a problem. And now that we've made that change, for me, there's no going back. I think that it makes things that much easier to make predictable UI.
All right, Mark, we have last question. Any plans to support other CSS pre-compilers besides GSX?
I'd say no, and I think that for me, the big reason is that I genuinely think JSX is something that actually makes this possible. So I've worked with React without JSX before, just using the function syntax. I did that quite early on. And if I had to, I could make that work. I'd still be using React probably. But I think what JSX does is it really lowers the barrier to entry for people who maybe have just dabbled with a bit of HTML, but coding wasn't really their thing. And I think you get a lot of that in the design space. A lot of designers who've dabbled with the web but haven't gone very deep. JSX, I think, makes it that much more approachable for people who don't have a technical background.
Thank you so much. That was Mark Dalglish.